Hi, today we need to find the maximum possible output of sin y minus x minus sin y plus sin x. Obviously, x and y are both real numbers. Okay, first we take a look at the overview of the function. First, we observe that the function makes infinitely many contours that extend from negative and positive values of x and y. Some output of the function are shown. At 2.5, the graph is much more smaller compared to 2.3. And at 2.6, the function cannot be graphed. Then we can say that the maximum possible output of the function is between 2.5 and 2.6. To find the exact maximum value, first we need to take the partial derivative. In terms of x, the derivative of sin y minus x is cosine y minus x, and because of chain rule, we multiply by the derivative of the inside, and the derivative of y minus x in terms of x is negative 1. Minus sin y is considered constant, so its derivative is 0, and the derivative of sin x is cosine x. In terms of y, the derivative of y minus x is cosine y minus x, and the derivative of the inside is just 1. And the derivative of minus sin y is negative cosine y, and sin x is considered constant, so its derivative is 0. Rearrange the equation, we have dy over dx equals negative cosine y minus x plus cosine x all over cosine y minus x minus cosine y. We must set dy over dx equals 0, which implies that the numerator part must be equal to 0. Cosine y minus x minus cosine x must be equal to 0. Our goal is to make this function only in terms of x. Since cosine y minus x minus cosine x equals 0 cannot be directly substituted into the original function, we need to note that sin y minus x equals square root of 1 minus cosine squared y minus x, and cosine y equals square root of 1 minus sine squared y. If we have cosine y minus x minus cosine x equals 0, we transfer the cosine x in the other side and we square both sides. We have cosine squared y minus x equals cosine squared x. Substitute the value of cosine squared y minus x equals cosine squared x into this equation. We have sin y minus x equals square root of 1 minus cosine squared x. Square root of 1 minus cosine squared x is nicely sin x. Now, we already have one value that we can substitute into sin y minus x. The next step is to work out with the value of sin y. Cosine y minus x same as cosine y cosine x plus sin y sin x, and we copy the cosine x equals 0. Substitute the value of cosine y. We have square root of 1 minus sine squared y cosine x, and we transfer the two terms into the other side. We square both sides, we have 1 minus sine squared y cosine squared x equals cosine squared x minus 2 cosine x sin y sin x plus sine squared y sin squared x. The left side of the equation becomes cosine squared x minus sine squared y cosine squared x. Rearrange the equation and cancel out cosine squared x. We have sine squared y cosine squared x minus 2 cosine x sin y sin x plus sine squared y sin squared x equals 0. Factor out the sine squared y on the first and the third term. We have sine squared y cosine squared x plus sine squared x minus 2 sin y cosine x sin x equals 0. Cosine squared x plus sine squared x is equal to 1. The equation becomes sine squared y minus 2 sin y cosine x sin x equals 0. factor out sin y, we have sin y times sin y minus 2 cosine x sin x. The solution for sin y is 2 cosine x sin x. Substitute the value of sin y minus x and sin y into our original function. We have sin x minus 2 cosine x sin x plus sin x, which is equal to 2 sin x minus sin 2x. Take the derivative of 2 sin x minus sin 2x to find the maximum value of f. The derivative of 2 sin x is 2 cosine x, and the derivative of sin 2x is 2 cosine 2x. We set equal to 0 to find the maximum value. We can cancel out 2, and cosine 2x same as 2 cosine squared x minus 1. Now we have negative 2 cosine squared x plus cosine x plus 1 equal to 0. Use the quadratic formula to solve for cosine x. We have negative 1 plus minus square root of 1 plus 8 all over negative 4. We'll get cosine x equals negative 1 half or 1. If cosine x equals 1, sin x equals 0. If cosine x equals negative 1 half, sin x equals square root of 3 over 4. Clearly, cosine x equals 1 and sin x equals 0 does not give the maximum value. So we use the cosine x equals negative 1 half and sin x equals square root of 3 over 4. So we have 2 square root of 3 over 4 minus 2 times negative 1 half times square root of 3 over 4, which is equal to 3 square root of 3 over 2. And this value is approximately 2.598076, which is almost 2.6. Therefore, the maximum output of sin y minus x minus sin y plus sin x is 2.598076. Okay guys, that's all. Thanks for watching.